Perfect. Hello, Dragon.
Hello.
Okay, Dragon decided to turn off his camera. All good, all good. We're all friendly here.
This is a relaxed session. Has
This
anybody
is-
brought
yeah,
lunch, by
hello.
the way? Who's brought some foods? Can we see? Cup of tea, a
Karin
banana.
and Henry. Just come
The rest of the lunch already.
Nice.
Maria's here.
Hello, Maria.
Hi, Richard. I
Hey.
had a message from Mike saying, just sending me the link saying he's stuck in court. So he said, "Oh, do you fancy joining?" So I was like, "Okay,
Wow.
here I am."
So Mike
You
does
were
work for a legal
doing-
company. He's not in court, right? He's not on a driving
No,
offence or something.
no.
Just to...
Let me just make this clear. Mike is
Context.
defending people in court. He is the lawyer.
Good, established.
And yes, I do. Yes, I do have my lunch with me.
Excellent.
Oh, great. That's great. we should really make ourselves comfortable. This is a relaxing introduction about an extraordinary topic while having lunch. So feel free to keep your camera on, feel free to eat, to share the meal, maybe share some recipe from if the meal is specialty from your country. So yeah, it's official. Welcome to the first Lunch and Learn session hosted by MKAI with Agnes. Agnes is a PhD candidate at the Knowledge Media Institute, the Open University, working under the supervision of Professor Enrico Motta in the Intelligence Systems and Data Science ISDS Research Lab. Her research interests lie in the areas of cognitive robotics, computer vision, neurosymbolic learning, and knowledge engineering. She also holds an MSc in Information Sciences and Technology from Pennsylvania State University and Master in Industrial Engineering and Management from Politecnico di Torino. She has contributed to many interdisciplinary research projects, both in academia and industry, and her work has appeared in the top-rated peer-reviewed venues, such as the International Conference on Principles of Knowledge Representation and the Reasoning, and the AAAI Symposium on Combining Machine Learning and Knowledge Engineering. Wow, what an introduction. Such a great work, such a great work. Congratulations.
Incredible.
So,
Thank you, Alex.
We'll start with the official part. The podium is yours.
Thank you. Thank you so much. I'm so happy to be here today, meeting you all for lunch. So I'll start sharing my screen to show you a little bit more about my research. Hopefully you can see the slides.
Yes, we can.
Mm-hmm.
Awesome, thank you. So yeah, as Alex said, I'm currently a PhD candidate in KMI. So I'll tell you a bit more about my work, but bear in mind that of course, it's not just my work. So it's been done under supervision of Professor Enrico Motta, Dr. Enrico Daga, and also with the input of my colleague Gianluca Bardaro. You may recognize some of them in the audience as well today. And first, I wanted to tell you a little bit more about why I'm passionate about robotics and what is the motivation behind this work and why I think it's a potentially really disruptive technology that can have a real impact on society. And if you think about it, there are many cases where we may have an incentive to delegate tasks to robots and not intervene firsthand. So the most painful and recent example was the COVID emergency because we were forced to social distance. So we had to find new ways of working and resort to technological interfaces to do that. Also, there are cases where there may be fragile patients or people that need that have their needs met, but can't really provide for themselves. So if you're local to Milton Keynes, you may have used the Starship robot delivery system. That's another great example of integrating robots in the urban systems But also there are many scenarios that can be risky for us in manufacturing, in rigid climates. You see here the little rover that was used to explore Mars. And so one prototype that we wanted to focus on in our lab was health and safety monitoring in the office. So we named this little robot Hans, like health and safety. And the idea is to have a robot that can check that the fire extinguishers are in place, that the emergency exits are kept clear, and there are no obstructions in between, etc. And another project that our lab is currently involved on is the Gatekeeper EU project. And in this project, the targets are fragile patients, and the idea is to provide assistance to the users at home. And there are many things that need to work and be put in place for this to happen before we can rely on robotic assistants in general and use them reliably. And for example, the first challenge you can see here in the video is that the robot needs to be able to navigate the environment, avoid all the obstacles. And while it's doing that, it's also perceiving the environment through a camera and through a depth sensor, and it's trying to map the different objects that are in the environment. And while it's doing that, is creating this map of the environment, and it is incrementally building a model, a 3D model of the objects that can be updated over time. So essentially what we're trying to do is not only to perceive the environment, but also what we need is a higher level understanding of the situation, right? Because if you think about this example here, like even if you had 100% accurate object recognition system, which we don't have, by the way, but even if that was the case, for example, the robot may say, oh, this in the corner here is a carton box, without realizing that the carton box is being used as a paper bin in that particular office. So what would it need? It would need to maybe read that the carton box says paper bin, or it would need to observe the same environment over time, learn how people are interacting with objects, their uses, and get a better understanding of the situation. And when we get in the realm of this type of knowledge that is very experience-driven, we're basically having to deal with what we call common sense. The challenge with common sense is that the term common sense even is very vague. What is common sense? It's very subjective, it's based on culture sometimes, and it cannot be tied to any specific domain of knowledge like spatial knowledge, temporal knowledge, or knowledge of physics of the environment, for example. So we're moving from bare perception and minimal perception to a higher level understanding and sense making, or making sense of the environment. And of course, with such a complex problem, we can have many entry points to the problem. And during my PhD, I chose to focus on vision specifically as an entry point. And so the question I asked was, how do we build a robot that is more visually intelligent? And so what do we mean by visually intelligent? It's a robot that can use a vision system, but not only that, also that it has reasoning capabilities and that it has some level of background knowledge or awareness about the environment. And then the next question is, what makes a system, or what makes anyone visually intelligent, really? So us as humans, we're incredible at vision. Our vision system is really fascinating. So there is a lot that we can learn from the human vision system. And in general, what we do without even realizing it is that we maintain this model of our environment. And over time, we update it very efficiently, and we adapt based on everything that's changing or everything that may be uncertain over time. But what we do also is when we observe objects, essentially what is cast at the back of our eyes is just a 2D image of our surrounding. And even the 3D that we see is built mentally. So that's really fascinating, I think, because there's a lot of brain power that is involved without us even realizing that. And we do very sophisticated things, like even we can maintain different representations of the objects based on their properties. And in particular, two groups of properties that are very, very important to categorize objects are their physical properties, for example, their size, their materials, and also the fact that objects can have different parts or they can be configured differently in space. So I chose to focus specifically on these two forms of reasoning in my PhD. And also, as I said, all these complicated processes happen really fast and really efficiently. So that's why there was a lot of buzz and also hype around deep learning, because these technologies were really disruptive in that sense. And there is a lot of inference power that can be used by relying on deep learning. However, like all methods, they come with their own limitations. So as we're doing research, we're also trying to test the boundaries of what deep learning is able to do. And here I wanted to show you a couple of provocative examples of where deep learning failed in our case. So on the left, you see here that an armchair was mistaken for a mug, presumably due to the shape of the armchair, because the system has no awareness that mugs are actually way smaller than armchairs. So we hypothesize, okay, what happens if we give the system that awareness that some objects are smaller than others, etc. And also on the right side here, there was this window with the blinds on and it was mistaken for a radiator. But again, if the system was less of a one-shot prediction and it could observe the same environment over time, it would know that maybe radiators don't usually float in midair, and that usually in that particular office, there are radiators somewhere else, and that's maybe a window. So that was the idea behind developing this system that starts from deep learning, but only uses deep learning as a starting point to add additional knowledge and awareness about the environment, with a focus specifically on size and spatial knowledge. So for example, here you can see the fire extinguisher was misclassified as a bottle, again, due to visual and shape similarity. But then what happens if the system is aware that bottles are typically way, way smaller than fire extinguishers? And what happens is that if the system notices other spatial cues in the image, for example, this object is very close to a sign that clearly says, hey, there's a fire extinguisher here. So with these cues, we can get hopefully one step closer to correctly identifying the object. And to do that, we not only need some reasoning capabilities, but we also need to represent this knowledge of the typical sizes and spatial relations of objects. So my proposal for representing this type of knowledge was to sort objects by their relative size. And you see, it's a very intuitive and qualitative sorting, because on the X here, you have objects ranked from extra small to extra large, depending on their front area. And on the Y here, you have objects ranked by their thickness from flat to bulky. And then some clusters start to form based on the object size. But what we need to do is also to allow for the same objects to be added to more than one quadrant at the same time. We don't want these clusters to be too exclusive, because, for example, if we have a box, the box could be completely small and flat, or it could be assembled and have a completely different appearance. So to handle this extreme variability, we need to have a representation that is adaptive and flexible enough. Then for representing the spatial relations of objects, the idea was to represent relations in a way that is close to the way we talk about space in English. So we consider the point of view of the robot that here is marked with the colored arrows. And we said, okay, how do we extract the information that a fire extinguisher is on the left or of another fire extinguisher, or that an object is on the floor? And to do that, things became more complicated because, of course, when you represent spatial relations geometrically, everything is very clear-cut and well-defined, and it can be tested mathematically in a 3D space. But when you create this bridge towards language becomes very ambiguous. When we talk about space, sometimes we use different expressions with various meanings. Like here, I want to show this example of the on preposition that is probably one of the most ambiguous one we use when we talk about space. So we would say here that a cup is on the counter, but we would also use the same preposition on to say that a sign is on the wall. But the spatial meaning of these two sentences is very different, because on the left, the cup is sitting on top of the counter, whereas the sign is affixed on the wall. So it's a horizontal intersection between the two objects. So we had to do some work here to define the different cases where we use a preposition in a way that we could map to the type of data that the robots records in the environment. And once we had all these components together, so again, an object recognition module, other modules that improve the object recognition by considering also the sides and the spatial relations of objects. We wanted to put this all together at use for the application of monitoring and health and safety in the office. And of course, there was a reality gap. It's always happened when you deploy things on a real robot. There were some challenges involved. First challenge being a hardware challenge, because we want things to run smoothly and efficiently on a mobile platform that is navigating the space. So for example, we use the TPU accelerator for the deep learning part, and we reduced very efficiently the number of examples that the robots use to learn a new object type, so that it wasn't too much of an expensive process. But also, in addition to that, the robots would need other things in addition to object recognition, right? So it would also need to know what are the health and safety rules that are important at the office, or for example, other facts about objects, not just the size or spatial relations, like knowing which objects are flammable, or which objects can spark a fire in certain situations. So there is also this causal knowledge involved that supports the robot's decisions. And here I wanted to show you a couple of examples from a real monitoring routine from the Hans robot. So here the robot has correctly identified 2 fire extinguishers, right? And then it also recognizes that one is on the left of the other and both are fixed on the wall. So then we can add additional common sense knowledge that tells us general facts about a fire extinguisher, like it needs to be inspected, or sometimes it gets cold. As you can see, not all these facts are pretty reliable. They're extracted automatically, but the idea is to collect as much information as possible that is relevant to that object to support further understandings of the situations.
So Agnes, what's the coolest thing that you have learned from this process? You mentioned a few really interesting examples of what were the challenges and how you solved them. What's the coolest thing or some situation that you remember from this real life experience, from this situation?
Right. So I think it was really interesting to learn how things need to be adapted to the robots, because like coming from a background where I was mostly programming just on my laptop, it's a completely different world. So then when you need to take the same systems and deploy them on a robot, there are all sorts of things that can go wrong. So you need to account for all the connections even of the hardware components, and how the robot may, for example, sometimes for the robot, it may even be difficult to locate itself. So maybe you're running everything and the robot doesn't even know where it is and it needs to relocate. So there are these challenges, but then it's also part of the reward, right? So when everything works, it's also, you see a real tangible thing that is going around the lab, and that's really exciting too.
Indeed, perfect. Thank you.
Yeah. Yeah, so this was just to show you a couple of examples of how the robot actually can understand the situation. And in this case, say that, for example, there are fire extinguishers that are on a supply stand, that they are unobstructed, but it didn't recognize that they're labeled. So, but this is due to the deep learning not even finding the sign. So again, back to the challenges that I was just mentioning, like it's important to see what system didn't work and why. It was explain the results and get a better sense of why the system is making certain decisions. And as a last example, here is an example of a fire threat, because there is an object that is close to a flammable pile of books. So here it's important to have additional knowledge of cause effects, right? So an electric heater can cause a fire and it has a property ignition. So by reasoning on this graph, we can conclude that an object that is combustible is in close proximity to a source of ignition. So that would cause a warning in our system. So yeah, hopefully just to tie up this part, I convinced you that visual Sensemaking is very important to build a real robotic platform. And we're just at the beginning of the challenge, because there are indeed many components that contribute to this sense of visual intelligence. And at the moment, the deep learning system are expediting this process, but they're still vastly limited, especially if you compare them to the way that us humans make sense of the environment. And in this system, I try to experiment how size and spatial awareness may help in these scenarios. But of course, there are a lot of exciting directions. We're just starting in this field, and there are still a lot of open challenges that can be tackled. And I think one of the very interesting ones is also defining better what does it mean for systems to have intelligence, to have common sense, and how can we go about it in a way that is as fair as possible. Yeah, so that's all for my presentation side. Thank you very much.
Thank you, Agnes. Thank you so much. It was so inspiring presentation. And as Jaisal mentioned in the chat, there's a really super cool examples. So I would like to ask you, what does a typical day look like in your field? So is it something similar to these examples or completely different? Just to make people more comfortable what it looks like in real life.
Yeah, I think there are in the PhD in general, there are various types of typical days. So one would be the type that I just showed you, the trial and error on the robot and actually interacting with the machine and trying to make things work. But there are also other days that are more writing heavy, where we need to read, be on top of everything that's happening in the field, learn new things constantly to see how our field is evolving. And so yeah, it's pretty diverse and engaging position, I would say.
Wonderful, thank you. Nabil, you mentioned that you're working on the same problem. Can you share a little bit with us, perhaps? we know your project, but let's introduce it to other people in the audience.
Thank you for the wonderful conversation. I'm sort of working on the same sort of problem, and when you said, it's quite amazing what the human mind can do in your presentation. This is exactly what I was thinking about yesterday when I was staring at an artifact. And trying to understand, how a computer actually recognizes it and compared to what we can do on the fly, and we don't even recognize what we are actually doing. So I'm researching on CNN, convolutional neural networks, to identify depth and to identify spatial awareness in art. So I've just spent the last 3 weeks. I've got a background in artificial intelligence and robotics, but I've never really got into it till now. And this is the subject area I'm trying to sort of apply artificial intelligence on. So I've just spent the last 3 weeks basically researching, what is the state of art. And where are we at, and what are the different systems and convolution neural networks, or what is the research? And I came to the same conclusion after reading, mostly everything and watching a lot of online tutorials and all of that, that you need to classify different aspects of an object. So what I thought about yesterday is very, very much what you just said today, that you're trying to classify additional information about an object, and because in a lot of the work that's online today, that's sort of missing, because there is additional information in every object that we see, that the human mind just sort of does it on the fly and we don't even recognize. So from a point of view of a painting, it looks like what is fascinating is that the painting behind me, it would look like a 2D object, and you would be like, oh, that's just a 2D object. What's so fascinating about that? And that's what your brain would say. It's just being, but it has edges, it has depth, it has it has different surfaces, and it would have so many complicated items in it, which the human mind just perceives so easily, which a computer just can't. And you have to and you have to go through all of these complicated algorithms. And I don't think there is anything out there till this day, although we say artificial intelligence has actually addressed most problems, but it really hasn't. I think it's still really far away, and there's a lot of work to be done. So yes, my work is involving art and artificial intelligence.
Thanks for sharing. It sounds like a super interesting topic, and also I think more so in your case. I mean, I agree 100% with you and on your view on the field and where we're at. But also more so in your case with artworks, there are these extra layers of style, I imagine, even without working too much directly in that. And, emotional layers of interpretation of the artwork that
exactly.
We're just scratching the surface, probably even more.
Yes, I mean, I was just staring at a painting yesterday, in the looking out in the abyss and thinking, wow, my brain just thinks about all of these things. And I'm just beginning to realize that if I want a computer to recognize all of those things, this is just scratching the surface. There is so much work to be done in order to even get somewhere. So it's very, very, very impressive.
Yeah, many opportunities to keep working in that. I think it's really fascinating indeed.
It is indeed. Thank you so much, Nabil, for your insights, and Agnes for your reply. Richard, you raised your hand.
Just because something Nabil said really made me think. Agnes, what are your reflections on the military use of robots and drones, given what we've heard today? You know, I don't need to give a political opinion, but just generally.
Yeah, I think as with all technologies, there are uses and misuses, right? So I'm quite, thank you for your questions, because I'm quite conscious about like doing research on this. There are actually people who were, you know, developing computer vision systems like YOLO, and then dropped out of the work they were doing because they've been used militarily. So it is a concern. I think there is always a choice to make a conscious effort to focusing on applications that are for the good. So I'd like to think that I will only focus on AI for good. But of course, like with all fields, innovation is also driven by where the funds are. So I'm not surprised that sometimes there are some application scenarios that are more military driven. I think there is, however, sometimes robotics and AI in general gets a bad reputation because we hear more about the apocalyptic or negative scenarios, and but there are also, I think, many scenarios where actually this technology can make a difference for the better. And I hope I showed 2 or 3, but there are many more.
Just to
can I step in on this question?
Yeah, but my question was slightly more about the mistakes and whether or not.
Can I just comment on the military element?
That's what I wanted to talk about. If there are errors and mistakes and lack of common sense, is it not a bit premature to be using these in military? That's kind of what I was.
Yeah. Well, I just would like to make a point that we don't do. I mean, we since the foundation of the Knowledge Media Institute, we never had any grant from the military. We don't do military applications. I mean, it's a tenet of our research, and exactly because I think you need to be clear about the boundaries where you apply your technologies. So yeah, it was more of a general question, really. But, you know,
is there a sense that, you know, we're not ready to have autonomous weapons, given the conversations that we're having today about the challenges with common sense in robots?
Can I add to that? However, most of research is just published. I've just watched the most cutting edge research played out on YouTube for the last, and discussions on papers. And so even if we don't take direct funding from military, usually papers are published and the information is published, and it doesn't take much to recreate or to after the hard work of the researcher is done, it doesn't actually take much to recreate knowledge,
Yeah, but I think, so to answer the question, are we ready for that? So I think I wouldn't see a motivation for doing that, even if we were ready. But plus, I think we're very far away to being able to rely on this system too much, even in the friendly and positive applications that I was showing, let alone where, of course, the decisions are much more critical.
Thank you. I apologize if I didn't mean to put anybody on the spot about military. It was just a question of, in other worlds, other things are doing, it's a glimpse. Right, that's what I was getting at.
Oh, good. We're here to have an open discussion, for all questions are welcome.
Developing military applications, let's just be clear.
Yeah. But Richard, I think this is a very important point. This is absolutely important point.
Yeah.
Yeah, so then Agnes, Enrico, can you share your vision of the future of robotics on the brighter side and on a nice note? What is your vision of future of robotics, looking from your aspect of working?
Enrico, do you want to go first, or?
No, you go first. You're
okay.
You're the speaker.
Okay, so well, I think my vision specifically is that. What I hope, at least, is that there will still be much opportunity to keep working on these technologies, and also that we can get, like Nabil was saying, like right now we're just in the beginning of testing what these systems can do. But moving forward, we would need systems that are more explainable in the type of results that they produce, and also that where we can incorporate things that are more human-like for some things. Like for vision, it makes sense to have systems, in my opinion, that are more cognitively inspired. But for other applications, it may not be the case, because in the case of vision, we excel at that. But in other cases, where we may introduce our own biases in the system. So it's also very important, I think, that longer term, there is more an evolution on the side of regulation and on the side of defining what is ethical and non-ethical, back to also Rita's question as well, and also kind of develop that to see where it is important to use what we're good at and where the system is maybe fairer than us, and we don't want to embed our own biases in the system.
Yeah, that's really interesting insight. We have a couple of questions and comments in the chat as well from Henry Muhammad. We'll go back to this just in a moment. So there is also a question. Is it a question of the scope of AI against conscious intelligence when making some important decisions? So the question is around awareness and the consciousness, because as Richard mentioned, if deep learning struggles to recognize a cup versus a chair, we should really give it more attention and see how our systems being developed and deployed. So the consciousness, the awareness, how important is that, and from which aspect should we look at that? From a more philosophical, from a more technical aspect, joint?
I really feel I've pushed us off. Angelo, why don't we go back to Mohammed's question, which is a bit more relevant. Let's not go into
I think Harry was fast. I think Harry had a question about the knowledge they encode. I don't know if you can see Agnes in the chat. 11,
yeah.
30. Yeah, maybe we can start from that one and then go down the chat.
Yeah, so Henry makes a very interesting point about my approach being also dependent on the type of knowledge that is encoded. Yes, absolutely. So is there a possibility to use DL methods to improve on the overall coverage to avoid mistakes or missed opportunities? Yeah, if I understand the question correctly, there is also an opportunity, I think, to use deep learning to discover new knowledge. One thing that I haven't explored so much so far, but I would like to continue looking into, is how we actually evolve this knowledge over time. So as you said, we start from a prior of knowledge that is pretty much encoded, and that's the limit. But again, ideally, we would like to have models that can learn incrementally. And also another thing that we do really well, but machines don't do so well, is to reuse concepts and generalize in different scenarios. So a question becomes then, how do we model this knowledge so that we can recompose different concepts in different scenarios and expand? Like, for example, what if we learn new objects that we haven't seen? And but by doing that, we also need to observe an environment for a longer time and collect as many information as possible. But certainly, yes, there are many uses where deep learning can automate the process. My argument is that deep learning is not enough alone, so we would also need some knowledge-based systems to help moderating everything.
Wonderful, thank you so much for your answer. So we had a really interesting question from Henry. We also had from Muhammad. Muhammad asked, did you consider deep reinforcement learning technique for robot learning? Just out of curiosity.
Yeah, I'm not a super expert in deep reinforcement learning, to be honest, but I'm really fascinated by the topic. I think there is a lot of work that is promising in terms of also robots learning by demonstration. And I haven't touched much on the human-robot interaction part, but especially not only, as you said, using reinforcement learning and a reward system, but also I think using other systems where the human is more in the loop in the teaching of the robot. I think it's a very interesting possible application.
We want to hear you, Alex. We just see your mouth.
You're muted, Alex,
I'm sure you were talking like the brightest thing, so we want very much to hear you.
Indeed. I just wanted to go around the room. I see a few cameras on. I see Jerry, Henry, Alan, Marcus. Would you like to share your thoughts on this? So if you have some questions, feel free. Oh, Haiming, do you have a question?
Yeah, thank you very much, Agnes. Is really good talk and very interesting.
Thank you.
Yeah, you mentioned a bit just before the last question about involve human into the loop. I'm more from the my research is more from the aspect of involving users into the loop for the intelligence. So I guess my sort of question or comments more from the explainability perspective. So from your research, we can see there's a challenge to actually let the robot to model human brain. But on the other hand, if, for example, in one of the example you give is the robot didn't identify the sign of the fire distinguisher, so therefore it gave a cross for that item. So it failed the safety check. But how would this can be actually communicated with the people or with the users in the loop? I wonder whether you think we should focus now on the robot to model human brain, or we should actually tackle the problem from both ends?
Yeah, this is an excellent question. I think there is always the possibility to, let's say, create a synergy between different benefits, right? So on the one hand, yes, I would love to see systems that are more human-like from the standpoint of vision, and also because if we communicate with the user, for example, for the spatial relations, we want to communicate in a language that the user can understand. If I told it the fire extinguisher is on the north 45 degrees, it wouldn't understand anything about what's happening, and it would not be able to give me any feedback. But as you said, again, there's also this untapped potential of learning things from the user in turn. And so, yeah, that would be a very interesting application to try to see what happens when we notify the fire wardens in our case, and see how the dialogue between the human and the robot could evolve in that case. There's one thing I didn't have the time to investigate so far, but it's also, I think, worth, whenever the scenario also, it's always worth to talk with the people who are already working on this type of things and see what are the use cases that are most useful for them. Because again, I think it makes sense to involve robots if they can collaborate with people ultimately and help them where it makes sense. It's not intended as a replacement of people again.
Wonderful, thank you.
Thank you for the question.
So we have one more great question from Helen Gold. So it is about, what are your thoughts on the robot asking for help or clarification if the robot has a low confidence in identification of an image, or if a rule is being followed? So what are your thoughts on the robot asking for help or clarification?
Yeah, that's certainly a case where the human in the loop may be a great source of help because, yeah, again, the way the system currently works is that if the deep learning confidence is low, then we activate other reasoners that can help the prediction. But again, as you said, there were some cases where maybe there is a false alarm that is being raised. And so in all those cases, I think there would be ideally a transition time where the robot is still trying and learning and then tweaking and refine until it is more reliable. So yeah, of course, it would make total sense to involve the humans for clarifications or providing extra rules or providing feedback about what the observation currently is.
Wonderful. Thank you so much, Agnes. Helen, would you like to add something to these insights? You feel free to. Oh, yay. Hello.
So no, I think I was just kind of curious about how that could work. And in terms of the confidence, I assume the system is working on whether it's a high confidence in the result that it's kind of going with, or if it's a lower confidence. And then how do you get from that low confidence up to a much more higher confidence? And I think you answered a good chunk of that. And I think that you were starting to talk about other systems that help to kind of get activated and can contribute to having a higher confidence result, if I understand correctly.
Yeah, absolutely. So that's the case, for example, in our spatial reasoner, we actually manipulated the deep learning confidence considering other scores based on the typicality of the relations. And so, so based on the typicality of the spatial relations, we modify the score. So that's what's technically done. The issues typically are where the algorithm is super confident about something that is super wrong. So that's where we need to put more thought into that and see how we can provide a more correct feedback.
Okay, thank you.
Thank you.
Wonderful questions today. And Yuzu, would you like to ask something? Someone here in the audience. We were shooting questions.
Yeah, I would hear actually to hear more about what other people are doing, like similar to what Nabil shared earlier. Like,
indeed, that would be really cool. So feel free to open your mic, whether you're working in the robotics field or you're just enthusiast looking hungry for some knowledge. Feel free to open your mic. We'd like to hear more about your work.
We were looking at case studies for greener construction and drones, actually, and we found that if we could reduce accidents on site and incidents, then there's less chance of injury, and therefore you can rely more on the local workforce. And that if the more injuries there were, the more lost personnel there were, the more you'd have to start taking people in further away. You would have to commute. So your health and safety has into the project, which I thought was quite
very interesting.
In 5 workshops at MKAI October, where we're showcasing 5 different types of technologies: green construction, analytics, the Tesla feedback, in them, and 2 others that from my read. I'm sure it'd be great to still DO you about that. Yeah, sorry. Yeah, just
we couldn't hear you, but we know that it was a great thing. All good. Okay.
I'll let everybody know. Don't worry, separately.
This will be a mystery until it will be revealed in MKAI channels. What's a life without a little mystery? Maria, you turned on your camera. Would you like something to add? Your experience, insights, thoughts, wishes?
Nope, it's all been very interesting, particularly from a lawyer sitting in listening. So no, it's incredibly interesting to hear everything that's going on.
Wonderful. Thank you so much. Alan, would you like to add something? Haiming, Nabil?
I've worked with, I also work in the OU and Knowledge Media Institute, and I've worked with the folk in the room on a number of different things. And for a long time, from the days of MK Smart onwards, we've been also investigating in a number of different scenarios, kind of assisted artificial intelligence, if that makes sense. And I was really pleased to see a couple of local MK instances of this as part of the MK 5G project, one of which was the idea of home delivery hire cars, which can be autonomously delivered to your home for you to then drive off in. But currently doing a great piece of work where they actually have a remote driver. So they've got a guy sitting in an office who's driving this car on the road using a PlayStation setup and a number of screens. Currently still has an actual driver in there, not to frighten anyone. But I know that that particular idea of rather than leaping to direct or autonomy through artificial intelligence, but to supported artificial intelligence has been quite growing in a number of different areas. And it comes back to that question of, how does, what methods are Agnesi and the team building into their work to allow their robot to be supported either through asking questions or to be diverted from the thing that it's doing, I suppose. So I don't know where you are with all of that, Agnesi, about it's a bit like the Starship thing. I mean, the Starship is the absolute perfect model of that, right? It runs around and becomes autonomous. So if it's going to crash, somebody steers it off the road into a different way, So it's where are you with that kind of thinking,
Yeah, I think it would be great to investigate. So far, I was more in the part that is kind of a prerequisite to that. But absolutely, I would be very interested in moving forward, exploring more how the system can actually interact with the users. And I think also, as you said, there's a question of how to prioritize depending on the type of questions that are being asked. So, and of course, there's a whole set of challenges associated to that. So, yeah, pragmatically, we started from, okay, we need a solid, not solid, but pretty much solid baseline to start from. And then, yeah, moving forward, a natural evolution would be refining the system also based on the user input.
Nice, thank you so much. So we haven't heard from Mel. Mel, are you there? Mel Alfieri, Gianluca, Julian, Renato. Hello, Mel. So nice to see you.
Yeah, really interesting. Thank you so much. I'm a bit like Maria. I'm on the professional services side, so we're blown away with all this great stuff that's going on. So I'm all about the R&D and supporting you with that funding for innovation. So yeah, please connect with me or get in touch if you need to know more on that. For all this great work that you're doing, you need to be rewarded.
Thank you so much.
Thank you, Mel. That's amazing. So who else? Gianluca, Julian, Renato, Angelo. Am I pronouncing it right?
Hello, can you hear me?
Gianluca.
Yeah,
yes, we can.
Actually, I work directly with Agnese. We are colleagues. So you already saw part of my work in the presentation. I'm actually in charge of the Gatekeeper project. So I work on the, let's say, other side of these same activities. And my application are more in healthcare, actually elderly assistance. So basically, we are using the very similar technology, of course, the object recognition and the reconstruction of these, let's say, 3D representation of the object recognized to support elderly people at home. And what we do is we try to create a safe environment for elderly people. So, for example, by removing possible obstacles close to doors on top of the stairs or similar, and to help them find and retrieve some of personal or useful items. So basically, that's what we do.
So nice to hear from you. It's a really brilliant work that you have been doing, and it's so inspiring, and we're so happy that we had a chance to hear more about it today. So, Haiming, you raised your hand.
Hi. I just want to ask a question to the team, the project team, including Enrico as well, of course. Currently, the project, are you using a combined of the content-based visual modeling, or you are actually working on a combined, like multimodal based modeling, including like image features you are looking at, as well as the knowledge base you mentioned? Are you actually combine the two together, or you are just purely working on the image and the visual based analysis?
No, actually, we're definitely combining the two parts. So for analyzing the image, we only consider visual features first, but then we also try to extract other features and go from that to see if there's a knowledge base that backs up that observation, so to speak. So if it's confirmed by the knowledge base and what we know that may happen. For example, if we have another knowledge base that says fire extinguisher on the floor these many times, then we use that information to say, okay, how frequently does this information occur in a textual knowledge base? And we try to incorporate that as well.
There is also a question from Ellen, which actually is very interesting, about the viable path for health and safety.
Yes, very interesting question. Thank you, Enrico. I'll read it. So based on your work so far, do you think there is a viable path for health and safety robots to be utilized?
Yeah. Can I answer that one? Yes.
Of course. Yeah.
Yeah, actually, I think Gianluca might have been involved. Some time ago, we had a discussion with the people at the MKAI Lunch Stadium. They're quite interested in the use of robots for a number of services, and health and safety was mentioned. I think we're really not very far away from being able to deploy. I mean, in fact, indeed, already Agnes's robot. It's not far away from deployment, and of course it's the usual thing, to go from research to an actual deployment in a commercial setting or in a urban setting. There is quite a bit of work, but yeah, I won't say. I don't know whether you agree, Agnes. I won't say there are any major obstacles from the current state of the technology to go to a concrete application in a concrete setting. Would you agree, Agnes?
Yeah, I agree, especially like it depends on the setting, of course, but there are many cases where the robot can already help without too much sophisticated intelligence. Like if you think about an industrial scenario where the robot can just map the temperature to see if there's some part that is overheating, or if you want to check the level of noise or other things that can be risky. There are some things that can be done really at a low level of processing the sensor data, even before doing this work to introduce more sophisticated intelligence. So yeah, I think it's looking good in terms of possible applications already.
Thank you so much for your insight, Agnes and Enrico. And we are 2 minutes past 2 in the UK, but we have time just for one more question. Marcus, you raised your hand.
I did indeed. Thank you very much for the presentation, Agnes. That was very interesting. Also for some of the work I do. As some of you know, I do a lot of drones and AI and augmented flying. And I've put a YouTube link a little bit up there because there's a new drone come out this week. It's actually not available yet, but some people have them to review it. And that is part of that. And that shows the drones built in obstacle avoidance system, and also APAS, which is called, I think it's called Advanced Pilot Assistance System. And what that can do in terms of real life computing, a particular, unusual shapy objects like trees, all sorts of things. You can see that in the YouTube video, but that is, to me, the technology is there, consumer grade. You can buy it in the shop from next week. It's amazing. It's not 100% working, but it's very, very close to what is possible right now. And I recommend you have a look and check it out, because you might get some learning lessons from what's consumer grade out there right now, and how they try to solve some of these problems that you no doubt also come across. Thank you.
Wonderful.